of DM Cecil Grady. I am going to teach function for class 11 mathematics. In previous video I have given concept of relation. Now I am going to introduce function and kinds of function, operation on function. Today I am going to discuss, student, what is function. What is function? What is function? A student, function is a special type of relation. Function is a special type of relation. In detail I am going to discuss for function if A and B are two non-empty sets and an association F which associates each and every element X belong to A to an unique element Y belong to B such that Y is equal to Fx, then F is called F from set A to set B. This is the differentiation. Here you try to understand language. If A and B are two non-empty sets in an association F is a association which associates each and every element of X belong to A के each and every element को to an unique element Y belong to B such that Y is equal to Fx, then F is called function from set A to set B. It is denoted by, it is denoted by F is a function from A to B or A to B function F. In this way we can denote function. Here each element of set A should be associated with element of B. No element of A should be left. So by diagram I am going to discuss before you. By diagram, suppose it is set A and elements are 1, 2, 3. Here B, A, B, C. Here 1, 2, 3 are the elements of set A and set B has element A, B, C. So 1 is related to A under function F, 2 is related to B under function F, 3 related to C under function F. So it is a relation. So 1 is related to A under function F, 2 is related to B under function F, 3 is related to C under function F. Each and every element of set A must be related with unique elements of set B. It is a function. It is a function. Now here we can say F1 is equal to A, F2 is equal to B, F3 is equal to C. Here we can say, student, A is the image of 1 under function F, B is the image of 2 under function F, C is the image of 3 under function F. So ABC are image. A is the image of 1 under function f. B is the image of 2 under function f. In this manner, A and B and these are images. Also, one is called pre-image of A. 2 is called pre-image under F. So on. 3 is pre-image under F of C. So these are set B elements are image and set A elements are pre-image. So it is a function, student. Now I am taking example which is not a function. So I am taking other example which is not a function. Set A, set B and 1, 2, 3, 4 A, B, C. If one is related to A under function F, related to C under function F, it is not a function, student, because 4 is not associated to any elements of set B. So 4 is left, so it is not a function. So it is not a function. It is a relation. It is a relation. Because 4 is left. It is left. It is not associated with any element. So it is not a function. It is a relation. Student, every function is a relation, but every relation is not a function. You keep in mind. Every function is a relation, but every relation is not a function. I am taking other examples. Other example, student, it may be possible that it is C, it is D, G is a function, C to D, and here 1, 2, 3, 4, 5, 6, here is A, B. It may be possible that more than one element of this, more than one distinct elements of this related with single elements of this. It may be possible. It is a function. More than one distinct element may be related with single elements of set B. More than one distinct element, it may be related with single elements of set D. So it is a function. No elements of set C are left. It is a function, student. It is a function. It is a function. Now, I am taking other examples also to clear the concept of function. H is a function from C to D such that C element 1, 2, 3, 4 and here is A, B, C, D, E, F. So 1 related to A under function H, 2 related to B under function H, 3 related to C under function H, 4 related to D under function F. Here we see that all the elements of set C are related with elements of set D. It may be possible that some elements of set D left, but no element of this should be left. It is a function. It is a function. It is a function. Because here we see no elements of set C are left. All associated with elements of D, so it is a function, student. It may possible elements of D were not associated with any elements of set C, so it is also a function. So various situations are there for a function, but main thing is that no elements of set C will be left, all will be related with this, and no two elements of this will associated with. Here I am taking C 1, 2, 3 and D, A, B, C. It is function H. So this, if I write this and this, it is not a function. Here it is not a, no two elements of set D related with elements of what? Not function. The student, more than one elements of C must be related with this, but more than two elements of D cannot be related with this. It is not a function, it is a relation. It is a function. It is a function. So these are the various situations of function to clear the concept of function, student. Now, what is domain and codomain, a range of a function, student? I am going to discuss what is domain and range. A function, student, domain. C is called domain of the function. Set C will be called domain of the function, and D, set D is called codomain of the function. It is called codomain of the function. It is called domain of the function. Now range of this function, range of H will be elements of codomain which are related with elements of domain, they are come under range. So we take only A, B, C, D. They only come in range of the function H. C to D is a function, then C is domain, D is codomain, and in range we take only A, B, C, D elements because they are associated with elements of domain. E and F are not associated, so they will not come in range of the function. So this is the domain and range and codomain of a function. How can you find domain, range and codomain of a function? Now student, here kinds of functions. Student, one is one-to-one function. One-to-one function. If f is a function a to b, is said to be one-to-one, then like this: a, b, 1, 2, 3, a, b, c. It is a one-to-one function. Single elements of domain associated with single elements of codomain under function f, it is one-to-one function. One-to-one function is also called one-to-one function, is also called injective function. Injective function. It is also called injective function. It is a one-to-one function. Now many one function, student, many one function f a to b, by picture we can show set a 1, 2, 3, here b, a b. Here it is a many one function. If more than one element of domain associated with single elements of codomain. This is a many one function. It is example of many one function. So these are the things. Now onto function, student, onto function. Here f is a function a to b. So set A, set B, 1, 2, 3, A, B, C. So it is a onto function. No elements of codomain are left. Here no elements of codomain are left. It is a onto function. It is also in 1, 1 and onto. So onto function is called surjective. Onto function is also called surjective function. So this function is 1, 1 and onto if to 1 and onto, so it is called bijective function. Bijective function. It is called bijective function. It is injective plus surjective is equal to bijective. So 1, 1 function and it is onto also. It is called bijective function because it is injective and surjective, so it is called bijective function. Now I come to the real function, student. Which function is called real function? Function if f a to b is a function such that A is a subset of real set and B is a subset of real set. If domain and codomain of a function are subset of real set, then f A to B is called real function. Student, in calculus we discuss whatever be the function that is the real function. Only we study real function in the calculus. So this is the real function, student. Now what is constant function? Constant function. A function f a to b is said to be constant if fx is equal to k for all x belong to a. सभी x के लिए अगर ये k के इक्वल हो जाए, that is called constant function. By figure, by diagram, we can show constant and a, b, c. Here is a k. So a related to k, b related to k, c related to k. So it is a constant function because fa is k, fb is k, fc is k. It is a example of constant function. Now student, we have to explain that is polynomial function. Polynomial function fx is equal to a0 a1x a2x square a3x cube up to so on a n x power n belongs to whole number is called polynomial function. Like that fx x square plus 3x plus 5 It is a polynomial function. Now rational function, student, rational function if fx is equal to gx by hx, where hx not equal to 0 and gx and hx are polynomial function, then fx is called rational function. As for example, student, example, fx is equal to x square plus 2x plus 3 by x plus 1. It is a rational function because it is a polynomial. It is also a polynomial. So this function is called rational function. This is a rational function, student. A modulus function fx is equal to mod x, where fx is equal to x when x is greater than or equal to 0 and fx is equal to minus x when x is less than 0. This is the modulus function. So when x is greater than or equal to 0, fx is equal to x, and fx is equal to minus x when x is less than 0. This is the modulus function. Here we take positive value like modulus minus 2 is equal to minus 2 is equal to 2. Modulus 2 is equal to 2. Modulus minus 3 is equal to minus 3, then 3. These are the modulus function. Modulus function, then student, greatest integer function. It is very integer function. So student, if fx is equal to, in this symbol in big bracket x, where value of this is equal to x, but not more than, value of this is equal to x, but not more than x. This is the integer function like that. And for example student, 0.5, here we take integral part only, this value is 0. 0.9, value is 0. Here we take 2.5, 2, we take only integral part. 3.9, this is equal to 3. This is the greatest integer function. Now, if we take minus 1.5, now we take here negative, so we take minus 2. Because it is less than this, so minus 0.8 is equal to minus 1. This is the characteristics of greatest integer function, student. In next video I will discuss signum function and trigonometric function, inverse trigonometric function, operation on function. In this video I also given concept of function and some kinds of function. Thank you.